Okay, we're going to be working in lesson 10.3 today, and we're going to be looking at operations, so like addition, subtraction, multiplication, with radical expressions, okay? And today our primarily focus is going to be addition and subtraction, okay? So we're going to start with some review problems here, because if you can do these, they're very similar to how you would attack these types of problems down here, okay? So if we just zoom in real quick here, review number 1. So if I have 2x plus 7x, we're just going to add those front numbers, right? So we're just going to add the 2 and the 7, and we're going to end up with 9x. Okay, so go to example 2 here. Now on this, again, you're just combining like terms. So we're going to start with putting together our x's first, and then we're going to put our y's together here in the middle, okay? So when I look at this guy, 12x minus 8x is 4x. 3y plus 6y is 9y. Okay, so again, you're combining like terms, okay? So now when we come down here to square roots, it's the same concept. But instead of having a variable of an x, now they just put a radical in. So this problem is very similar in that we're just going to take the 2 and 7 and add them up and still get the 9. But instead of putting an x here, we're just going to put the square root of 11 there, okay? So they have to have the same radical to add them up. If they have different radicals, so if the insides here are different, you cannot add them. So in this case, I'm going to get 7 plus 2 is 9, and then radical 11. Okay, so let's go to this guy. All right, so just like in the problem up above here, okay, so we put together your x's. Well, here we're going to put radical 5 and radical 5 together. Here we put the y's together. Here we're going to put the radicals of 7 together. So we've got 12 root 5 minus 8 root 5. So we're going to end up with 4 root 5. Okay? Then we'll go to the middle here, root 7s. So 3 root 7 plus 6 root 7 is 9 root 7. Okay? And that's going to be your answer. We can't add them up because they're not like radicals, just like we can't add them because they're not like terms. Okay? All right, I want you to pause the video and I want you to try to do C and D on your own. Okay, so looking at C here, okay, they all have the same square root. So square root of 5, square root of 5, square root of 5. So 6 plus 2 is 8, minus 5 is 3, root 5. So again, you're just combining like square roots. Okay, over here on D. Okay, put together your square roots of 2's, okay? So you should have got 7 minus 6 is 1, radical 2, or you could just put radical 2. I don't care if you want to put that 1 out front or not, that's up to you, okay? And then in the middle here, we've got the 8, radical 11 minus 4 radical 11. So we'll get plus 4 radical 11. And that is your final answer, because you can't add unlike radicals together. Okay, so now we're going to go down to E. Now, E changes just a little bit, because first off, you can't add any of these up because they're not the same. But the problem is all of these can be broken down. So if you can break them down, you have to do that. Okay, so I'm going to go ahead and start with this 27. That would go to 3 and 9, 3 and 3. 3's pair up and move out. So in the last lesson, we worked on this. What do we do when we have outside number? Remember, we're just multiplying. So 6 times 3 is going to be 18. And then I have this little 3 here left over. So it's going to be 18 root 3. Plus, break this guy down. So like 3 and 4, 2 and 2. 2's pair up and move out. So 8 times 2 is 16. And then we have a radical of 3 again left over right here. All right, let's go to the next guy. So 75 breaks down into 3 and 25, and then 5 and 5. So 5, pair them up, move them out, and I've got a 2 out there. So 2 times 5 is 10. And then again, in this case, I have a 3 left over, so I have square root of 3. All right, so now I'm taking a look. Are these like radicals? And the answer is yes. So then we're going to go ahead and add all these up. And we're going to end up with 44 root 3 when we add up all of those, okay? Okay, let's move on to the next one here. All right, so again, we don't have like radicals, but we have to reduce them anyway. So 20 goes to 2 and 10, and then 2 and 5. So 2's pair up and move out. So I have 4 root 5. Okay, 45 goes to 5 and 9. 9 would go to 3 and 3. 3's pair up and move out. So I'm going to have 9 root 5. All right, and then 180. So like 2 and 90, 2 and 45, 5 and 9, and then 9 would go to 3 and 3. So let's see, on this guy I've got a pair of 2's and a pair of 3's. So that would put a 6 on the outside, and then I have this 5 right here left over, so 5 on the inside. Now again, these are all like radicals, so we can go ahead and add them up. So 4 plus 9 plus 6 is 19 root 5. Okay. All right, so now this says find the perimeter of a rectangle whose length is and whose width is. Okay, so now think about what perimeter means, right? Add up all of the sides. So be careful here. Don't be that person that only adds up 2 of your sides. So if I kind of draw this out real quick, my length is 8 root 7 plus 4 root 5, right? And then I'm going to have another 8 root 7 plus 4 root 5 down here. Okay, and then my width was 5 root 7 and 3 root 5. So 5 root 7 plus 3 root 5. And then I'm going to go ahead and put that in on the other side as well. So 5 root 7 plus 3 root 5. So just make sure that when it says perimeter, we're adding all 4 sides and not just 2 of them. Okay? All right, so now combine like radicals. So in this case, I've got root 7, root 7, root 7, root 7. So all of those are going to be added up. So 8 plus 5 is 13. So 13 and 13 is 26 root 7. Okay, and then I'm going to go to the next one, put together all of my root 5s. Okay, so 4 plus 7 is, 4 plus 3 is 7. 7 and 7 is 14. So I have plus 14 root 5. And again, I can't add these up because the square roots are different. So this right here is my final answer. And then we should be labeling inches. It's not squared because it's not area. All right, and that concludes lesson 10, 3 notes on addition and subtraction.